All right, let's dive right into one of the most mind-bending questions in all of physics, a concept that feels like it completely breaks reality as we know it. The question itself sounds simple, but the answer? Well, that's a whole other story. What is actually happening to time inside a black hole?
So here's the big paradox, the thing we've all heard. As you get closer and closer to a black hole's event horizon, time, from our outside perspective, slows down to a crawl, and then it just stops. But what does that even mean? I mean, really, if time stops, how can anything happen at all? Let's figure this out.
Okay, so picture this. We're watching from a safe distance, far away from a black hole's insane gravitational pull. That gravity is so strong it's literally warping the fabric of space-time. This is what physicists call extreme gravitational time dilation. So if we were to watch, say, an astronaut fall in, we would see their clock tick slower and slower until right at the edge, at the event horizon, they'd look like they were completely frozen, just stuck in a single moment for eternity.
And here is the massive problem, the real head-scratcher. If time is truly stopped for that astronaut, then logically, nothing can change. There can be no movement, no chemical reactions, absolutely nothing. And yet, we know things must be happening inside a black hole. All that matter is getting crushed, energy is being transformed. So how can anything possibly be going on in a place where time itself has just ceased to exist?
Now, what's so fascinating about this is that the solution might not come from some brand new super complex physics. Instead, it comes from stepping back and asking a much more fundamental question. What even is time? It turns out we need a simpler and honestly a much more powerful definition.
This right here is the foundational idea that changes everything. See, time isn't some mystical river that flows on its own through the universe. It's much simpler. Think of it as just a measurement of change. If something, anything at all, is changing, then time is just the word we use to count and measure that change. I mean, think about a simple clock on your wall. You don't actually see some invisible force called time pushing the hands forward. What do you see? You see a physical change. You see the position of the hands changing. Each tick is just one little change, and time is our agreed-upon system for counting all those little changes. That's it.
So once you have that new definition locked in your head, the whole paradox starts to dissolve. It turns out the entire confusion comes from us mixing up two very, very different kinds of time.
So on one hand, you've got where we measure from the outside, our human perspective time. It's totally relative, it's warped by gravity, and yeah, from our point of view, it absolutely looks like it stops at the event horizon. But then, there's a more fundamental idea. Let's call it machinery time. This is the intrinsic rate of change that's happening inside a system. It doesn't care about an outside observer. As long as the system itself is still dynamic and changing, this kind of time just keeps on ticking.
And this is the absolute key. Just because our tool for measuring time, a clock or light signals, whatever, just because that tool breaks down when it hits the event horizon, that doesn't mean the actual underlying process of change stops. The internal machinery of the universe just keeps on running, whether we can measure it from way out here or not.
Okay, so we're armed with this really powerful distinction now. So let's do it. Let's take a little conceptual leap of faith. Let's step past that event horizon and see if we can actually prove, just with logic, that time has to exist inside a black hole. The logic is actually beautifully simple. It just unfolds in 3 steps. Step 1, we know for a fact that physical change happens inside a black hole. Particles are interacting, energy is shifting, it's a dynamic place. Step 2, we stick to our new powerful definition, that time is simply the measure of that change. Well, the conclusion is just unavoidable, right? Therefore, step 3, if change is happening, then time, by its very definition, must exist in there to describe it. And just like that, the paradox, it's gone.
So, what's the big takeaway here? This isn't just about solving a cool puzzle about black holes. This shift in thinking gives us a completely new way to understand the nature of time itself. The upshot is actually pretty profound. Time isn't some external cosmic river that everything is floating in. It's our tool. It's a label, a concept we invented to measure and count events. And if change is happening anywhere, and I mean anywhere, even deep inside the event horizon of a black hole, then time has to be there too. The logic is just that clean and that powerful. And that really leaves us with one final big thought to chew on. This black hole paradox seemed absolutely impossible, but we managed to unlock it just by going back and questioning a really basic assumption we all had about time. It really makes you wonder, doesn't it? What other huge mysteries of the universe are just sitting there waiting for us to look at an old, familiar idea in a completely new way?